Hello, and welcome to today's lesson, our last lesson in our Area Volume 3 unit. We're going to be working with two shapes today. We're going to be finding the surface area of cylinders and the surface area of cones. Okay, two formula-driven values, but we want to understand how the values are created and how we can work through to find these solutions. And then we'll finish up looking at an application on how we can find the surface area of 3-day shapes with missing pieces, cutting a hole out of the middle or doing some other alterations to the shape itself. So when we look at the area of a cylinder, what we always want to do when we're talking about surface area is break it up into the individual pieces. The pieces that we have for a cylinder, as we can see, we have a circle on the top, circle on the bottom. Both circles are radius 4. And we know the area formula for a circle is pi r squared. So here is the portion of this cylinder that's made up of the two circles. So we've got 2 pi r squared. Now, what we call the lateral area of the cylinder is actually a rectangle that wraps all the way around. You know, if you take a piece of paper and you roll it up, you make a cylinder. So when we look at that piece of paper, the height is the height of the cylinder itself, but the base length of that lateral area is the distance that wraps all the way around a circle, or better known as circumference. So our circumference, we've got 2 pi r, or 2 radius pi, however you want to look at that value overall. And that's how you can see the two parts. Okay, there's the base of the rectangle times the height of the rectangle. Okay, so this is how the surface area of a cylinder is pulled apart or built overall. Now, what we want to do, plugging in our values that we have, we've got 2 radius squared pi, and that's our area of the top and bottom circle, plus 2 radius times the height pi. Just wanting to put the pi's on the end to make our mathematics work a little easier, a little cleaner. So 4 squared is 16. 16 times 2 is 32 pi, plus 4 times 12 is 48. 48 times 2 is 96 pi. Okay, and then we finish up our surface area by putting those pieces together. So we get 128 pi. Okay, it's always best to leave it in exact terms. Okay, if you do end up multiplying by pi, we want to understand that there's a big difference, if possible, between 128 times 3.14, okay, 401.92, and 128 pi, okay, the exact value, okay, 402.12. Okay, so you really want to be careful. You want to be as exact as possible, either using the pi button on your calculator or leaving your answer in exact terms. And in this case, we should always be tacking on our units, centimeters squared. Okay, now the next shape that we're going to be looking at is the surface area of a cone. Okay, when we look at a cone and we cut it up, it's very easy to see that the bottom of the cone is a circle. Okay, so we've got a circle radius 3, so we can see that we have the pi r squared piece to it. Now the hard part is, what shape is the lateral area of a cone? Okay, and when you actually cut a cone apart and lay it flat, what you end up with is a sector. Okay, we have a sector. Now in this situation, we don't know the degree measure. So if you think back to when we were doing area in our area of sectors, we knew the degree measure, we could find the proportion of it. Okay, but what they do, or what we can do and use for our surface area, is we use the radius, because we can see that the radius is involved in making this cone. But then we also use what's called the slant height. Okay, this is an edge distance from the top of the cone to the outside of the radius. Okay, and that's called the slant height, and that's where the second part of our formula comes from. So we've got the circle, pi r squared, and then we have the sector. Since we don't know degree measure, what we do is we use pi times radius times the slant height to build the area of that piece or that surface of our object. So now, finishing up, we've got a radius of 3, so we've got 3 squared pi for our circle, plus our lateral area that wraps around the outside of the cone. We have 3 times 7 times pi. So we have a 21 pi for our lateral area, 9 pi for our circle on the base, and we put those two together and we get a surface area of the cone of 30 pi. Okay, the importance there, once again, since we don't have a degree measure, we're using pi times RL, okay, radius times the slant height, and using that for our area of the sector, and then we have the area of the circle on the bottom. Okay, so now, taking a look at an application of this, we want to find the surface of the hollowed out cylinder. Okay, so what we have is we've got a cylinder, top and bottom. Okay, top and bottom are annulus or washers. Okay, so we're going to have to find the area of the washer. And then the hard part about this problem is not only is there an outside wraparound, there is also an inside wraparound. Okay, so we've got 2 rectangles that we have to look here because we have an inner circumference, okay, and that's surface area on the inside, and then we have an outer circumference. Okay, so we have to have those 2 pieces. Okay, so when we look at it now, we've got the pictures that we need to build together to get our surface area of this object. And remember, when it comes to an annulus, we know that we have a big radius squared pi minus the little radius squared pi. So it's big circle minus little circle. Okay, and that's going to work in here because we're going to have a little circumference, okay, 2 little r pi times h, and then we're going to have the big circumference, which is 2 big r pi times h. So we've got these extra pieces here because of the fact that we're dealing with a hollowed out cylinder overall. Okay, so we've got 9 for our big radius. So we've got 9 squared pi minus 5 squared pi. 81 minus 25. Okay, and that will be our pi value. Okay, it's Monday morning here, so I'm going to cheat and use a little calculator work here to make sure I get this one right. Okay, we've got 56 pi. Okay, now we need to work into our 2 rectangles. Okay, we've got our outer rectangle, 2 times 9 times pi. Okay, and don't forget our height. We've got our height of 15. Okay, and then we have the small rectangle, 2 times 5 times pi times the height. Okay, so we want to have these pieces here. Okay, so we've got 18 times 15, or 270. Okay, and then we have 10 times 15, 150. Okay, now, there's one piece that I've missed here. I want to see if you can notice it. I found the area of the annulus on top. I found the area of my inside-outside lateral spaces. What's missing? This is a very common missing piece. People forget about the bottom of the shape. Okay, so we've got the 56 for the top, 270 for the outside, 150 for the inside, and then we need another 56 pi for the bottom washer, the bottom annulus. Okay, and then to finish up, we're going to put all these pieces together. So 270 plus 150 plus 2 times 56. And we get a total surface area for the object of 532 pi. And then we're always looking at our units. We've got centimeters squared. Okay, so that was finding the surface area of cylinder, surface area of a cone, and then the surface area of a hollowed out cylinder. Thank you and have a good day.